Okay, this video we're going to be finding the volume of a torus formed when a circle radius 6 that's centered at 8, 0 is revolved around the y-axis. It's asking us to use first the shell method, then the washer method, and then it'll ask us to evaluate one or the other integrals because they will give the same answer. It's just two different methods. Okay, so for the shell method, let's write down that formula. V is equal to the integral from a to b of 2 pi x. Okay, and we will be integrating with respect to x when we're using the shell method. Okay, and that's f of x. There we go, f of x minus g of x dx. Okay, so first let's figure out what our limits are, our a and our b. Okay, so if we look at this shape over here, and this shape is creating this torus, which is a donut kind of. So you can look at this as the circle we're looking at, and it gets rotated around this thing to create this donut-like shape. Okay, so that's where the 2 pi comes from. That's the circle. Okay, and then the rest of this stuff we're trying to figure out what this shape is right here, the volume of that shape. Okay, so our limits, if we look on the x-axis, we're starting at 8 because it says the circle is centered at 8, and the radius is 6. So this is 8. The radius is 6, then over here is 2 because 8 minus 6 is 2. And over here is 14 because 8 plus 6 is 14. So our limits are a is equal to 8 minus 6 equals 2, and b is equal to 8 plus 6, which is 14. Okay, and now for the function itself, what functions do we put in here? Well, we have to create that ourselves. This is a circle centered at 8, 0. Okay, so that would look like this: x minus 8 squared plus y squared equals the radius squared, which is 6 squared. Okay, this shows the shift to the right. Yes, it's supposed to be minus. It's opposite on the inside. Okay, and this is the radius. We need to solve this for y because we're dealing with functions that have x. Okay, so we move this term over by subtraction. So that will be y squared is equal to 6 squared minus x minus 8 squared. And then we take the square root of both sides and make sure to put the plus or minus. Square root property says you have to put a plus or minus when you take square root in an equation. 6 squared minus x minus 8 squared. Okay, so that's our two functions that we're going to split this up into. The top one will be f of x, that will be the positive one, and the bottom one will be g of x, which is the negative one. Okay, so our integral that we're going to set up is 2 to 14, 2 pi x, okay, and it will be positive square root of 36, that's 6 squared, minus x minus 8 squared, minus because of the formula, minus because the second one is minus, so minus minus, same thing. Okay, 36 minus x minus 8 squared dx. Now, if you're minusing a minus, that's adding, right? So eventually, or essentially, you'll be adding these exact same things up, and there's two of them, right? So that would be v is equal to from 2 to 4, 2 pi x times 2 of the square roots of 36 minus x minus 8 squared dx. And if you wanted, you could bring this 2 out here and make that a 4. Okay, let's do the problem again, this time using the washer method. Okay, and for that, we're going to be integrating with respect to y. Okay, and that will be v is equal to the integral from a to b of pi times f of y squared minus g of y squared dy. Okay, so that does not look much like a 2. That's a little better. Okay, so this is the formula we'll be using. We need to find our limits, just like last time. Okay, so our limits this time aren't left and right, they're up and down. Okay, so the center is 0 because it's right here, not up, not down. It's right on the x-axis. So the upper one would be up here, which would be at 6, and the negative one will be down here, which would be negative 6. We know that because the radius is 6. Okay, so the limits is a equals 0 minus 6, which is negative 6, and a equals 0 plus 6, which is 6. Oh, that's b, excuse me. Okay. And now for the function's still going to be a circle centered at 8 comma 0. So it will be x minus 8 squared plus y squared equals 6 squared, which is 36. That's the radius. This time we're going to solve for x because we're dealing with functions of y, so we need to get y over here. Okay, so let's move that y squared over. So that's x minus 8 squared equals 36 minus the y squared. We can square root both sides, so that will give us x minus 8 equals plus or minus, that's the square root property, 36 minus y squared. And then we can add the 8 to the other side, so it'll be x is equal to 8 plus or minus the square root of 36 minus y squared. Upper function, or f of y, lower function, g of y. Okay, and we have our limit, so now we just plug it in, and you get from negative 6 to 6 pi. Okay, and remember we're getting squared. Okay, so here's I may not have room on this. Let me move down here. Okay, so v is equal to from negative 6 to 6 of pi, and then we've got f of y squared, so 8 plus square root of 36 minus y squared, and then minus 8 minus square root of 36 minus y squared dy. Okay, so now that we have that, we need to figure out what those are once they get squared out. Okay, so let me write that right here on this one. If we have 8 plus the square root of 36 minus y squared, that's the same thing as multiplying it by itself. Okay, so we multiply it by itself. Okay, so first term times first term, that's 64. The first term times that term is 8. It's the square root of 36 minus y squared. And now this term times the 8, it's the same thing. 8 times 36 minus y squared. And then the last one would be this one times this one, which just means the square root goes away. So plus 36 minus y squared. Okay. Now we can combine like terms. We have them right here. So it's 64 plus 16, that's the 8 plus 8 of the square roots. And then plus 36 minus y squared. Oops, you can't see. Okay. Let's do the other one real quick. The only difference is it'll be subtraction. So 8 minus the square root of 36 minus y squared times 8 minus the square root of 36 minus y squared. So everything's the same on the multiplications except we've got a minus sign here. So the first one's still 64. The second one would be negative 8 of the square root of 36 minus y squared. And another one of those, this one and this one, negative 8 square root of 36 minus y squared. And in the last term, negative times a negative is a positive. So that goes away, and the square roots also go away, so you still get 36 minus y squared. Combine like terms, you get 64 minus 16 square root of 36 minus y squared plus 36 minus y squared. Okay, that's the second one squared out. Okay, so take a look at that for a second. I'm about to write that all right here. Okay, here it is written. Here's the first one, and here's the second one. Okay, notice that we have a negative sign that goes in here. So let's think about what's going to happen when I distribute that negative sign. The first one, it's going to become a negative 64. We've already got a positive 64 over here. So negative 64 and a positive 64 are going to cancel. We distribute here, and it becomes positive 16 of this square root. We've already got a positive 16 of that, so that's going to combine in my next and become 32 times the square root. We'll do that in a second. Let's see, here we got positive 36. Here we have a negative that gets just distributed here, and it makes this a negative 36. So those two, positive 36 and negative 36, will cancel. Here we have a negative y squared, and we have one here too, but the negative distributes and make this one positive, so that one also cancels out. So you get a bunch of cancellation, and then on the inside you get v is equal to, here we go, and the 16 and 16 makes 32, so I'll put the 32 before there, square root of 36 minus y squared dy. Okay, the last thing it said was to evaluate the integral. So I'm going to evaluate the integral with my TI-84. Okay, so calculator looks like this. Okay, so I go to y equals, there's the function, 32 pi square root of 36 minus x squared. I had to use x squared because that's the only variable you can put it into the graph on this, so I just pretended it's an x squared. And then I go ahead and take the integral. So second, trace or calc, go down to the seventh one. See it right there. That's the integral. Lower limit. Actually, we can't see it. So let me do something first. You can hit zoom and you can go down to zoom fit. It's the 0 one there. And it should give you a graph that you can at least kind of see. There we go. So there's kind of what the graph looks like. And now we can get a visual as it's taking the integral manually. So negative 6, positive 6, and it'll take it just a second, and there we go. So my integral, which was taken manually by the calculator, gives me an answer of 5,684.89. And that's it.